Hello everyone. Today in this video we are going to learn about closure property, commutative property, associative property and the property of identity. So let's start on the journey of the properties of whole numbers. Very firstly, we are going to see the closure property of addition. So here we see a few examples. Here we see 7 plus 1 is equal to 8. So we see 7 and 1 both are whole numbers. When we add both of them, we get again a whole number. Let us see one more example. In the other example, we see 20 and 30 both are whole numbers. When we add 20 and 30, we get again a whole numbers. So what we understand from this is that the sum of whole numbers is always a whole numbers. This is known as the closure property of addition, and this means that addition is closed under, whole numbers are closed under addition. Now we proceed further and we check if this is applicable with subtraction also. So we just check the closure property of subtraction. So here we have one number, whole number 7, the other whole number 1. So 7 minus 1 gives us 6, which is absolutely a whole number. Whereas in the other example, if we check, 20 is a whole number and 30 is also a whole number, but when we do 20 minus 30, we do not get any answer. That is because 20 is a smaller number and 30 is a bigger number. So what we conclude is, when we subtract two whole numbers, we do not always get a whole number. So this means that whole numbers are not closed under subtraction. Now we'll check this with multiplication. So here that 7 is a whole number and 0 is also a whole number. When we multiply 7 with 0, we get answer as 0, which is again as a whole number. Here in this example, we can even see 7 multiplied by 10, we get 70, which is a whole number. Now another example, we see 30 multiplied by 2. 30 and 2 both are whole numbers. When we multiply both of them, we again get a whole number. So this means that when two whole numbers are multiplied, the answer which we get is always a whole number. This means that whole numbers are closed under multiplication, and this is known as the closure property of multiplication. Okay. Nextly, we proceed further just to check if this is applicable with division also. So, closure property of division, here we see 70 is a whole number, we divide it with another whole number 10. The answer what we get is 7, which is a whole number. Now let us try with some other numbers. We try taking 2 as a whole number divided by 3, another whole number. But here when we divide 2 by 3, we get 2 by 3 or 2 upon 3, which is not at all a whole number. So what we understand is, if two whole numbers are divided, it will not always give a whole number. This means that whole numbers are not closed under division. Okay, let us take a break. Law of closure property. Now let me ask you a small question. That why did the two 4s not eat during dinner? Think. The answer is simple, because they already ate. That was just a light joke. We'll proceed further with other property of whole numbers, which is called as commutative property of addition. So here we see there is one basket which has got 1, 2, 3, 4, 5, 6, 7. 7 apples which are greenish. Other basket which has got 8 apples. So now if we add 7 and 8, we get 15. Now let us exchange the baskets here and there. So here we see firstly there is basket having 8 apples, and in the second position we have another basket having 7 apples. So now if we add 8 and 7, oh, the answer is same 15. So what we understand is that if the order of numbers are changed while adding, the answer still remains the same. This is called as the commutative property of addition. Commutative means that the numbers which we are adding can commute, can travel from one place to another place, but still they give us the same answer. Now let us check the same thing for subtraction, if it is valid or not. We'll just see commutative property of subtraction. So here we have two slices of bread, then we have one slice of bread. So here what we are seeing is, if 2 minus 1 is done, we get the answer 1. Now let us interchange the position and see if we get the same answer. Now we keep 1 minus 2. And then we see that 1 minus 2 is equal to question mark, because here we are not getting a whole number. So what we understand is that whole numbers cannot be subtracted in any order. Means whole numbers are not commutative under subtraction. Now let us check the same thing for multiplication. So here we can see, in commutative property of multiplication, we can see in all the three pictures, we can see there are two parrots each, or two birds each. So here there are altogether three pictures in which there are two birds each. So 2 multiplied by 3 gives 6. So now instead of taking 2 multiply 3, let us see another example where we have same one branch, where they have given two pictures of having one branch, and on each branch there are three birds, three parrots. So 3 multiplied by 2, here we get 6. So what we understand is that even if the order of numbers are changed in multiplication, the answer remains the same. So we say that this is the commutative property of multiplication. Even if the numbers commute or travel from one place to another, the answer does not change. The answer remains as it is, the same. And then we also check the same commutativity property for division. Let us check. So here we see that there is a basket having 10 dairy milk chocolates and there are 5 kids. So if those 10 dairy milks are to be distributed equally among all the 5 kids, then each kid will get 2. So this can be shown as 10 divided by 5 is equal to 2. But let us see if we do the vice versa, 5 divided by 10. So when I do 5 divided by 10, we get the answer as 5 by 10 or 5 upon 10. So here we see that the numbers cannot be divided in any order. So here we see that division is not commutative for whole numbers. Okay, lot of commutativity also done. Now we'll see a quick small question. If you have 5 apples and 7 oranges in one hand, and in the other hand if you have 6 guavas and 7 pomegranates, then what would you have? Very simple, you would have very large hands. Haha, that was again a joke. Now we proceed with the next property of whole numbers, which is called as the associative property. So here in this associative property, you can see 3 pictures, and in all 3 pictures you'll see 3 slices of bread, 2 slices of bread and 1 slice of bread. So here if I have to show it in the form of addition, I'll show it as 3 plus 2 plus 1. So in the first instance we have put 3 and 2 in brackets. In the second instance we have covered 2 and 1 in brackets, but we see that the answer is absolutely the same. Answer does not change at all. So we see that whole numbers have the property of associativity under addition, that if you change the order of numbers, there is no change at all in the answer remains the same. This is called as the associative property of addition. Let us check if such associativity is applicable in case of subtraction. We'll check that later. Here there is one example given where we have 234 plus 197 plus 203. So if we have to add it and get the answer in a quick way, then what we are going to use is we are going to make use of the associativity property of whole numbers, where what we do, whatever is easy for us, we enclose it in one bracket and try to get the answer quickly. Just as in this sum, if we check the units place, 4 and 7 and 3. So 4 and 7, if we add in the units place, we get 11. That doesn't make our job that easy. But if we add 7 and 3, we get 10, which gives 0 in the ones place. So that will make our job very easy. So therefore, 234 is kept separately, whereas 197 plus 203 are taken together in a bracket, because that will give us some answer which will have 0 in the tens and ones place, which is 234 plus 400. So our answer will be very easy. It will be very easy to find out the answer, that is 634. Now we proceed further to check the associativity of multiplication. So here we can see there are 3 containers given, each of which has got altogether 2 rows, and there are 2 columns and 5 rows. So in each crate there are 2 multiplied by 5, altogether 10. So like this there are 3, so we show it in the form of multiplication as 2 multiplied by 5 multiplied by 3. Now if we put 5 and 3 into one bracket, then we get the answer as 30, or else if we put in the bracket 2 multiplied by 5 and then we multiply by 3, we get 30. But here the easiest way is doing 2 multiplied by 5, because 2 5s are gives 10, which has 0 in the ones place, which makes our task very easy in case of bigger numbers. Now let us see other properties, that is associative property of subtraction. So now when we are seeing associative property of subtraction, just let us try with a few numbers. So here we have taken 7 minus 3 minus 4. So if subtraction is to be done by putting brackets, so first case the bracket is put across 7 and 3. So 7 minus 3 in one bracket minus 4. So 7 minus 3, which is put in bracket, that always has to be solved first. So the answer for 7 minus 3 is 4. Minus 4 will give us 0. Now let us see by changing the place of bracket. So 7 minus, and in the bracket is 3 minus 4. So here 7 minus we can write, but 3 minus 4 question mark. So here what we see is that the whole numbers are not associative under subtraction, which means that whole numbers cannot be subtracted in any order. Now we'll just check this associative property for division. Let us see how it works. So here in this sum we have 10 divided by 5 divided by 2. So if we take 10 divided by 5 in first position in bracket, then 10 divided by 5 gives 2, again divided by 2 will give us 1. Now let us change the position of bracket and check if this sum can be solved or not. So here when we change the position of bracket, 10 divide we keep as it is, inside bracket we put 5 divided by 2. So here 10 divided will be written as it is, and then 5 divided by 2 will give us 5 by 2. Again 5 by 2 is not at all a whole number. So this again tells us that whole numbers cannot be divided in any order or sequence. It means that whole numbers are not associative under division. Now we proceed further with another property, but before proceeding with another property, we would see that why natural numbers and whole numbers are different. Okay, before that we have distributive property of multiplication over addition. So here you will see there are altogether 4 rows of 5 columns each. So here we have 4 multiplied by 5 is equal to 20. There are altogether 20 boxes. This whole thing can be broken up into 2 parts as 4 multiplied 4 rows of 3 columns and 4 rows having 2 columns. So it can be written as 4 multiplied by 3 plus 4 multiplied by 2. Now the same thing can also be written as 4 multiplied by, into brackets we have put 3 and 2 because 4 is common in both the questions. And then when we solve, we get the answer again as 20. This is called as the distributive property of multiplication over addition, where inside the bracket they give 2 numbers which are added, which can be split which can be distributed and given to the number which is given out. Now we'll proceed further with the property of identity. So in this property of identity, it is very important to know the difference between natural numbers and whole numbers. So natural numbers are counting numbers. For counting, we use 1, 2, 3, 4, 5 and so on. Whereas whole numbers have got all the natural numbers plus 0. So this 0, which is included in the group of whole numbers, has a very special role. Let us see what is that special role. So here in the identity property, let us start with identity property of addition. So here we see 2 plus 0 is equal to 2. So one whole number added with another whole number 0 gives us the same whole number 2. Again, one more example, whole number 0 added to another whole number 5 gives again the same whole number 5. So what we understand, the moral of the story is 0 plus any number gives us the same number. So 0 is called as the additive identity for whole number. The 0 has a special role. Now we check the identity property of multiplication. So here we see one example, 2 multiplied by 1 is equal to 2. Now let us see another example where 1 is multiplied by whole number 34, we get whole number 34 again. So here what we see is, moral of the story, 1 multiplied by any number is equal to same whole number, again magic. Hence 1 is called as the multiplicative identity for whole number. Then we see one more property of numbers, whole numbers, that is called multiplication property. Here again we'll see some magic. What's that magic? 2 multiplied by 0 gives 0. Again 0 is being multiplied by 34. We are getting 0. So what we understand is 0 multiplied by any number gives 0. Thank you for watching and keep subscribing Shruti's online school for more of such videos. Thank you.